So, thanks for coming or staying to see my talk. Basically, I was in a first special interest group discussion a few weeks ago, and this fella who's probably in his 80s started talking about some bit of internet history that was lost on me. And so I did a little bit of digging, and I learned some things. And so some of you probably know all this, but maybe for some of you, you'll learn something. So back in the 60s, well, no, I'm actually going to do my talk. Who knows these people? This is Robert Oppenheimer and Leslie Groves. They were the driving forces of the Manhattan Project. So they didn't really ask whether humanity was ready for their invention. They just checked that the math worked. So who knows these folks, right? Maybe we could fix DNS, just make a giant list of hosts and distribute it as a MISP artifact. Anyway, so they gave us ARPANET, right? They were sort of like the driving forces in the early days of the internet, and they didn't really expect that it was all going to develop in the way it has in 2025. They were trying to build a resilient communications network for the U.S. defense. But who knows these folks? So this woman, Sharla Perrine, and her colleague, Paul Baran, are the people that I discovered myself the other day, and I want to tell you about them real quick. So back between 1960 and 1964, at the RAND Corporation, which was a kind of, sort of like MITRE, a little bit of a federally funded research and development corporation, still exists. I'm not saying it's exactly like MITRE. If you work for RAND, I'm sorry, but I'm trying to level set for an international audience. So this woman, Sharla Perrine, was coding Monte Carlo simulations using Octal assembly. Back then it was Octal on punch cards, Fortran, that demonstrated that you could have a distributed network where the routing decisions were pushed down to like what we might think about like the AS level, could lose half of its nodes and still function. And so this math and these Monte Carlo simulations got turned into a paper that was published in 1964, and this became part of the business case, so I understand, for the original internet and what convinced DARPA to fund ARPANET. So this woman, Sharla, she was not just a pioneer of the early days of the internet, she was a Girl Scout leader, she was a math tutor for years, decades, a supporter of the Santa Monica Library her whole life. She donated her library after she died, and she passed in 2023. And I was doing some research, and I found the real estate listing where they auctioned off her home because her husband had passed before her, and so they they got rid of the assets. And there, in a footnote on the real estate listing for her home in Santa Monica, it described her as the grandmother of the internet. And so I thought, that's interesting. Never really heard about all that. So why did we need a resilient network in the first place? So this, for some of you, may get the joke here. For others, not. This is a still from Dr. Strangelove, The War Room, the famous line, "There's no fighting in the war room." It's a great movie if you haven't seen it. But so we lived through one Cold War, and we're in a second one. And the internet was originally created because we wanted a communication system that would be resilient. So if there was a nuclear first strike, whether it was deliberate or accidental, that we had an opportunity to negotiate, to de-escalate, and to keep our command and control intact on the Allied side long enough for cooler heads to prevail so we didn't blast ourselves into kingdom come. This was the original business case for the internet. This is why the U.S. Defense Department paid for it. This was sort of like a suicide prevention line for nations. So Sharla's simulations prove this math, and the math convinced the funders, and the funders built the world we live in now. And you might say the rest is history. But then the internet didn't stay the same. It wasn't built to stay the same, and it didn't. We've centralized things into the cloud. We've changed the topology. The traffic patterns have changed. The threat model has changed. And I haven't been able to find evidence that anybody ever reran Sharla's Octal sort of punch card Monte Carlo simulations to double check the math. But if their model was correct, and they assumed a distributed network, then we've centralized everything into hyperscalers like Google and AWS and Azure. We might have changed some of the fundamental design assumptions of the original internet. So what I would like to do next, and I don't have all the capabilities myself, but I'm looking for collaboration partners. I'd like to figure out how, based on the original RAND papers and existing historical data, to rerun those Monte Carlo simulations today, first using their original inputs, check the math, and then to rerun this using our contemporary design pattern. So, sounds like that's my time up. There's my contact slide. Thank you very much.
Thank you.